Hello.
Good afternoon, Dr. Francis.
Yeah, good afternoon. How are you?
Good afternoon, sir.
Yeah, good afternoon. People eating salad, rice, and ram.
I don't understand again. Oh.
Can you inform the radio? So can start with it.
Okay, so I think let's just start. We're already five, so like I think other people will be coming as we go along. So that's maximize time.
So wait, like some minutes and start.
Good afternoon, Dr. Francis.
Yeah, afternoon. How are you?
Fine, thank you. Good afternoon, everyone.
Afternoon.
Madam Vivi, welcome, ma.
Thank you, IG. How now?
Fine.
Okay.
Good afternoon, everyone.
Good afternoon, Maria.
Yes,
Welcome.
Vivian, Dr. Francis. Good afternoon. Oh, Moses.
Good afternoon, Maria.
Hi, IJ.
All right, I think we can start now, right?
Yes.
All right, let's start. All right, good afternoon, everyone.
Good afternoon.
Good afternoon.
Who did not join us last week was from now on, if you did join us, anytime you come and join us, as if we are inside in space. So who did join us last week?
For me, I joined a bit late last week.
You joined a bit late last week. So you notice that once we come late now, whatever we are going to be doing will be sounding like Greek.
That's true.
Is it not? It will be sounding like Greek. So that's why from now on, once I just noticed that those that who are considered coming will just continue, right? Because if I have not been practicing what we have been doing since at this stage, there's no point unless you go through the previous videos, or unless you just watch what we are doing. But basically, what we have entered is machine learning, right? We have entered machine learning, okay? And we know basically when we're talking about using Python, we showed you that for Python, there are different aspects of what you use Python to do, isn't it? And we talked about basically what we have used Python to do is data analysis, data visualization. We see again why most people use Python again is to also ensure automation. Okay, automation. Right. Now you see, when you are using Python as data analysis, so everything you are doing in Excel, remember that's where your data analysis role ends. It ends up in data visualization. Okay, data analysis and visualization. That's where your role as data analyst actually ends. Okay, but somehow we also need to automate certain tasks. Okay, we need to also automate certain tasks. So that's why you see that with Python, it has different applications, okay? And one of the skills that we also see, because when we are beyond your visualization, we also need to do some prediction. So this may go beyond a data analyst. Okay, so this is where your task AI, okay? But machine learning comes before AI. Okay, machine learning comes before AI. For you to get to AI, you must first of all build a machine learning model. And what's the essence of this machine learning model is for you to be able to predict. Okay, and that's why you see that with AI now and automation, most jobs now people will say, am I safe now when everything is going to be automated? Can I be replaced by AI? Okay, and that's where everything is going into. Imagine people who were typewriters before, typists, isn't it? With computer now, everybody have to do it themselves. So gradually, some roles will start fading out. Okay, but in as much as we try to replace this, we cannot fully automate decision making to machine alone, right? So there must still be a human element of it. Okay, so that's why when we look at machine learning is just a study, just like saying you are studying computer algorithms. It's just a study of what computer algorithms. Okay, I want to talk about algorithms. We are talking about step by step, or patterns. You are looking for what patterns, step by step. Ultimately, you are looking for what patterns. You are using that algorithm to search for what patterns. Okay, so we'll talk about machine learning. Machine learning is just the study of computer algorithms, isn't it? To help you what predict behaviors. And normally, most times, this is done automatically. Okay, through experience. But when you say experience, now we are talking about the experience how machine learn. You know, like human being, like a child experience, you give him sweets. You know, sweet is good. You give him lime. He knows lime is not good. So he has experience. But for machine, how machine learns with what data. So the more data you put in, the more it's going to what learn from it. Okay. So when we talk about things like AI, for example, you can talk about your Tesla, isn't it? You can talk about your Google Maps. Those are part of what AI. They are using artificial intelligence to drive it. But you see, at the back end of that artificial intelligence is your machine learning. Okay, so machine learning is just an aspect of what artificial intelligence. So with machine learning, what are you doing? You are using what an algorithm, isn't it, to build what a model. And what is that model trying to do? That model is trying to do what some predictions. Okay, and it's doing the prediction based on what the data. And remember, your data, we can break the data into two parts. What are they?
Structured and unstructured.
Is it structured and unstructured? When we talk about machine learning, your data is broken into two parts. What are they?
Qualitative and quantitative.
Oh.
Okay, the test and
train and test data.
test and
Train and test. Can you see that? So you see, as you keep evolving, you see the language now will start changing. Even if it's still data, when a data scientist listens to data and they are talking about prediction, the only two types of data is thinking about is train and test. You see that? But although yes, it may also need to know whether it's qualitative or quantitative to determine. But when we talk about prediction, the kind of data we are talking about, they group them into two parts: train data and what test data. So what we are saying here in machine learning, we are using what algorithms, is it not? We are going to use what algorithms to build what a model. And the model is usually based on what data, and that data can be what trained and what tests. But it's mostly what the trained data we use to what build that model in order to make what predictions. Are you clear with it now? Are you clear with the concept? So AI is the umbrella word, is it not? Where we are talking about the applications. But at the back end of that AI is machine learning. So machine learning uses what algorithms to what build a model based on what the trained data in order to make what predictions. Clear?
yes, sir.
Good. Now you see, for your machine learning, right? It can be classified basically. We can use two words for now, what they call supervised learning and what unsupervised what learning. But some others can break it into three and tell you there's reinforcement learning, reinforcement learning. And that reinforcement learning is what they call deep learning. Deep learning, deep. Have you heard of deep learning before? Deep learning, okay? And it all can also be under your what unsupervised what learning. It's like the highest level. Okay. So your machine learning can be broken basically into two for now: supervised learning and what unsupervised what learning. Okay, supervised learning and unsupervised learning. So when we say supervised learning means that, remember we said when we are talking about machine learning, is it not? We are using what? We are using what? Algorithms, is it not? We are using algorithms. Sorry, algorithms. This is my eraser. So in machine learning, what are we saying? We are using what? Is the use of algorithms. What do we do with these algorithms? To build what? Models. We use the algorithms to build what? Models. And please, whenever we are talking about model, this model is mathematical, which means the simple model we are talking about is y is equals to what? A plus what? Bx. Okay, so machine learning is simply what? The use of what? Algorithms to build what? Models. Is it not? Based on what? Data. And this data we are talking about, most times it is what? The trained data. We're using what? The trained what? Data to what? Study the patterns in order to what? Make some what? Predictions. In order to make some what? Predictions. Clear? So whenever we are saying the model, this is the model we're talking about. It can be a simple regression model. It can be what? A multiple regression what? Model. But at the back end of most algorithms is your what? Regression. Okay. So we can talk about what? Supervised learning and what? Unsupervised learning. So we say machine learning can be broken down basically into two. The first one is called what? Supervised learning. Supervised learning. And what? Unsupervised learning. Unsupervised learning. Okay. Good. And we say under supervised learning, remember your model, y is equals to what? A plus bx. What differentiates it? This y, normally we call it dependent variable, isn't it? This x is called what? Independent variable, is it not? This your a is called what? A is called what? What is A called?
Intercept.
A is called your what? Intercept. B is called what?
Slope.
Your
Slope.
slope. Is it not? Good. At the end, you are going to get value of A, get value of B. It is this value of A and value of B with the predetermined value of X that will enable us to predict the value of Y. Is that how we do it in regression? So it means that in practice, this our Y is what they call what? The target variable. It's called what? The target. That's what we want to predict. That's called the target variable. Why this X is called what? The feature. It's called what? The feature or predicted variable. The feature. So target, feature. Okay? Which means when we talk about supervised learning, this target variable is known. Is known. Right? And is labeled. That's why it's supervised. We label it ourselves. We label it. We can say yes, no. You know, we can assign 1, 0. We can say fraud, no fraud. Is it not? It can be COVID positive or negative. Can you see that? So by nature, it may be binary or it can be binary. When you say binary, what does binary mean?
Ones and zeros.
1 and
Yes,
0, is it not? Only 2. Or it can be what they call, sometimes they use the word multinomial. Multinomial. That means it can have like, it can be 1, 2, 3, it can be others. It can be 1, 2, 3, but most of the one we use is 1, 0. Fraud, no fraud. Yes, no. Good, bad. Isn't it? Good, bad. And generally, anyone so that means that if it is positive, 1, if it is negative, we assign what? 0. So there's label to it. So it's just like you taking a child and giving the child and say sweet, yes. Line, no. And you see that you are telling the child that is supervision. Okay, that is supervision. So the moment you have your data, you now have to what? Specify your target variable. Okay, and say this target variable, we have to label it. Where it is true, we assign 1. Where it is false, we assign what? 0. So under your supervised learning, we have 2 algorithms. We have what? Regression. We have what? The linear regression. And we have what? What's the other one for supervised learning? Under supervised learning, we say we basically have 2 algorithms. What are they? Linear regression and what? Yes, linear regression and what?
Multiple regression.
Is it multiple regression?
Multiple.
Linear regression. You said linear can either be simple or multiple. That's different. Under machine learning, we say we basically only have 2 types. We have linear regression problem, isn't it? And what?
Logistical regression.
Which is called classification.
Classification. That's what it said.
Classification. Isn't it? So all these things we are doing here, they are all what? Classification. All these ones are under what? Classification. But how do we know when to use linear regression and when to use classification? How will you do? How we know when to apply linear regression algorithm and when to use the classification algorithm?
You said when it was depends on the type of problem. Is a classification problem?
Yes. Or
Based on the data sets.
yes, based on the data set. So we'll look at this target variable, is it not? If this target variable have numbers, when we say numbers, they are random numbers, right? It can be 1, it can be 2, it can be 10, it can be 20, right? When they are in this form, which means what we're trying to predict a value. What kind of problem is this?
Linear regression.
It's a linear regression, exactly. This is a linear regression problem. But where this target variable can be yes, no, is it not? We can assign 1, 0. It can be good, bad, is it not? Which can be 1, 0, isn't it? Or it can be true, false, which is what? 1, 0. What kind of problem is this?
A classification.
This is what? A classification problem. A classification problem. So under supervised learning, it can either be linear regression or what? Classification. So under your linear regression, you can have your simple linear regression model. You can have your multiple linear regression model. Okay. But under classification, we can talk about what? Logistic regression. We can talk about what? Logistic what? Regression. Are we clear with this?
Yes.
Good. I will say under unsupervised learning, we are not this target variable is not labeled. This target variable is not labeled. So you are not the one that will tell it yes, no. It will look at the features. It will look at the features. And what does it do? It will now cluster them. That is those with similar characteristics. It will put them in groups. Is it not? And now assign label that this is likely going to be group 1, this is likely going to be group 2, this is likely going to be group 3. But with classification, you are the one that will say this is group 1, this is group 2, this is group 3. But unsupervised learning, we automatically look at the data set and tell you, based on these features I am seeing, they are likely to be in this category, or in this category, or in this what? Category. So under here, we can talk about what? Clustering. Okay, we can talk about what? Clustering. So you have machine, some algorithms like what they call KNN, K nearest neighbor. K nearest what? Neighbor. Okay, so you have quite a lot of algorithms, okay? And what you are going to notice is that you see at the end of this, we said that machine learning is just what? An aspect of what? AI. Is that what we have said? So it
Yes.
means that if you see anything, you see like Tesla, you see like Google Maps, there's an aspect of this that they are dealing with. But the advanced level of this, your unsupervised learning, is what they call deep learning. It's called what? Deep what? Learning. So in deep learning now, this one is like it's generating its own data by itself, it's classifying them by itself, is it not? It's labeling by itself, so it's doing everything by itself. Okay, but not just with your normal structured data. It can be anything. This one, it can be pictures, it can be videos, it can be sound. Can you see that? It's more almost to reality. That's why this is the highest level of deep learning. So when you're automating this deep learning, automating that process, that's what they refer to it as what? AI. Okay, because when we talk about AI technologies, one of them is what? Machine learning. Okay, machine learning. We can also talk about RPA. Have you heard of robotic process automation? Have you heard of that? Robotic process automation.
No, sir.
RPAs.
No, sir.
No.
Yeah. RPA. It's just like any process you can think about, just automation. How can you automate that process end to end? Because you know, when we talk about robots, we just think about robots as like a toy, is it not, that is doing the human task. I think that's how we normally think about robots. But when we talk about robots, robot itself is not really to make you a human, make it a human. It's just performing human task. It can be embodied in a toy, is it not? Or it can just be what? A program, but it's doing the same thing. Right? So RPA is just what? Automating that process. So just like, for example, we can talk about, you know, like in Japan now, there are some hotels now, you don't even see human beings now. Everything is all robots. Is it not? Is the robot that welcome you, robot will usher you to your room. Is it? What are you doing? That's the robot process automation. Okay, but rather than you using that particular robot now, we are just talking about that whole process, rather than you looking at it as a particular object. So it's just talking about automating your whole process. So just think about those who are doing or producing in manufacturing firms, is it not? They are already processes, is it not, that are already what? Automated. Some are machines that are doing it. So at the back end of that machine is RPA. So think about like accountants now. You want to get invoice, you want to get you want to extract the number, you want to put it in trial balance, you want to extract, you want to analyze, you want to predict. All that whole process you are doing this RPA. Okay, then there's some that will talk about virtual agents. Have you heard of virtual agents?
No.
Virtual, you have heard of it. You know, sometimes on Instagram, right? Even WhatsApp, you say hello, somebody will respond to you. You wonder, are these people awake by this time?
Yes.
And those are virtual agents now. They are bots. They are bots. That is AI. They are bots. Yeah. The same thing you can look at. You can look at a picture, right? And this thing can look at a picture and tell you, you know, like for example, now how doctors first of all tell you, okay, go and do an X-ray. Do not take it, put it inside light, is it not? Put it inside light and then say, I can see growth, is it not? I can see a growth there. What does that indicate to you? Maybe seeing a growth or a lump based on the X-ray. What does that indicate to you? Or an MRI? What does that indicate?
It's showing that maybe there is something cancerous.
Something cancerous, is it not? So you want to automate that process. Can you see that? You are not trying to automate that. That decision is not taken. Oh, I look at it. Oh, it is likely to be cancer or not what? Cancer, isn't it? Now, when you automate that process, that is also referred to as computer vision. Computer what? Vision. So it's using pictures now, not just numbers. You see what? Pictures. So like Tesla uses this computer what? Vision. Even speech or text. Which one uses this one? Speech or text? Speech, like your Google Maps now. Is it not talking to you?
Yes, it does.
It's talking to you, is it not? That is speech.
Yes.
That is speech. So that one is referred to as natural language processes. Natural language processing, NLP. Okay? All these are different technologies in what? AI. Can you see that? So what we are touching here is just one aspect, which is what? ML. But it is this ML that drives every other one. Once you have foundation in this, you can use this one to now build on every other aspect. Is that okay?
Yes, sir.
Is that clear?
Yes, sir.
All right, good. So in practice, we have so many algorithms, so many what? Algorithms. We have so many algorithms, okay? We have so many algorithms, okay? The most common one we have seen is what? Linear regression. Is it not? Linear what? Regression. So linear regression is like the foundation of every other algorithm you are going to see. Linear regression that is there. You have so many, okay? And that common one is called logistic regression. Logistic what? Regression. Okay? You will see some other ones. You see like decision tree. Decision what? Tree. Okay, that's an algorithm too. You hear of SVM. SVM is called I think support vector machine. Support vector machine. Okay, all these are all different. These are popular algorithms. You see them they use in practice. You have Naive's Bayes theorem. You know Bayes theorem? Do you remember Bayes theorem?
Yes.
Yeah.
That Bayes theorem, the application of that Bayes theorem in the machine learning model is called Naive's Bayes theorem. They call it Naive's Bayes algorithm. So it uses that Bayes theorem. You have other one called KNN. Is it not? K nearest neighbor. Nearest neighbor. You know what nearest neighbor is? My nearest neighbor. So if I have group A, group B, group C. So if I have one here, who is it closer to? A, B, or C? If I have a point here, it's based on that, it's based on clustering, is it not? You could not assign whether it's A, B, C, is it not? So this one, we look at the data and now classify and say, based on these characteristics, it's most likely to be, and now give you a probability that maybe what? 80% chance is what? A. It may tell you that it is what? Maybe about 15% chance that is what? B, and 5% chance that is what? 5%, 15% chance C, and 5% chance that is what? B. What you are doing is KNN, K nearest neighbor. You also have K means clustering. So you have so much. Even under your decision tree, you also have another one called random forests. Random forest. This is a bigger tree than your normal decision tree. So it's called random forest. There's another one they call dimension reduction. Dimension reduction. Okay. You have so many, but these are the ones common ones in practice. You now have gradient boosting. Gradient what? Boosting. There's even one they call ADA boosting. ADA boosting. You see, so many. And remember, there's a theorem called No free lunch theorem. No free lunch theorem. What does it say? No free lunch theorem. What does that theorem say? No free lunch.
It says that there are not one theory that fits. There's no one algorithm that fits
All problems, isn't it? Exactly. No one algorithm to fit all problems. So that is why you see, as data scientists, you see why when we started talking about, first of all, you must have a good domain, is it not? You must have your domain. We'll now talk about what? Statistics and what? Mathematics, is it not? They will now talk about what? Computer what? Programming. Do you remember this part? So that is why for data scientists now, for you to understand all this, you need to go back to what? Statistics and what? Mathematics. So that you understand the conditions when to use what. Okay? And remember, we can use as many as we want. The most important thing is to check which model is the most what? Accurate. We need to find out which model is the most what? Accurate. Okay, which model is the most what? Accurate. Then we see, to talk about the accuracy, isn't it? There are other factors we also need to consider, because sometimes when these results come out, sometimes they may look correct, sometimes they are not what? Correct. So we must do something called, especially when you are dealing with classification problem. So for classification problem, we now deal with what they call confusion matrix. Confusion matrix, as the name implies, confusion. You know, very confusing. Okay, and what does that confusion matrix say? If we look at it when we are doing our prediction, it can either be so it can either be actual or predicted. Actual or what? Predicted. That means actual means it actually happened, the real data. Isn't it? Which is true. This is the actual data, which is what? True. Then this is what you are predicting. Okay? You can predict that it happened, yes, or no, it didn't happen. So this one can be 1 for yes, no, it didn't happen. This one you predicted that it happened. So this one you predicted yes, it happened. This one you predicted no, it didn't happen. Can you see that? You predicted yes, it happened, and predicted no, it happened. So when it actually happened, is it not? It actually happened, is it not? But you predicted yes. So which means this yes can be what? Positive. Yes, it happened can be what? Positive. Why this no is what? Negative. Can we see that? Yes is what? Positive. Is it not? Why no is what? Negative. So this one is actually happened. So you predicted it actually what happened. It actually, remember, yes is what? Positive, is it not? No is what? Negative. Do you remember that? Yes is what? Positive. No is what? Negative. Okay. And remember, this one actually happened. So if I predicted that it actually happened and it happened, it actually happened and it happened, is it not? So this is true, is it not? So it is what? True what? Positive. Can we see that? You predicted it actually happened, is it not? That is, it actually happened and you predicted it happened. It's called what? True positive. It actually happened, but you predicted that it did not happen, is it not? It actually happened, but you predicted it did not happen, is it not? So this is what? First of all, it's going to be what? False what? Negative. Because this no is negative, is it not? False what? negative. This one, it did not happen. Actually, it did not happen, but you predicted what it happened. Actually, it did not happen. That is a false, is it not? And you predicted that it what happened, which is what positive. So this is what false positive. Then the last one, it actually did not happen. Is it not? It did not happen, which is true, right? And it was negative, which is also what true, is it not? So this is true negative. Do we get it now? Have you seen the
No,
confusion?
Doctor, there's confusion a little.
Yeah, as usual, I was confused. Yes.
The second top right.
This one or this one?
Second top right, yes, FN.
FN, okay, yes. What happened?
I thought it's going to be true negative.
Okay,
it actually happened, but
now look at it. Look at it. Remember, you predicted that what?
It did not happen, but it happened.
Actually, it happened. Is it not? That means it happened. Is it not?
Yes.
But what you predicted, was true. Is it not?
Did not happen. Yes.
So that's why we have false there. False. It did not happen.
But it actually happened.
Yeah. So look at it. When you are looking at it, you are comparing these two. You are comparing this and this. Can you see that? It actually happened. You predicted it happened, and it's correct.
Okay. Okay.
The other one is that it actually happened, though, right? But what you predicted that it did not happen, which is false.
Okay.
You see that?
Okay.
Then it was actually negative. You know, that's why we are putting the negative there. So it is a false negative.
Okay, I got you.
That's it. So otherwise, and that way we would have just done it this way, or just to say, if this is yes, no, is it not? This is yes, what, no. Anytime we have yes, yes, is it not? Is true. Or no, no is what? True. Anytime this is different from, anytime this actual is different from predicted, it is what? False.
Okay.
Anytime it's actual different, it is what? False. Isn't it? But because this is positive and this is negative, this is positive and this is what? Negative. So this is a true positive. This is a false negative. This is a false positive. And this is a what? True what? Negative. Can you see that?
Yes, I can see it's correct.
Great. Now, which one do you think is more dangerous? False positive or false negative? Which one do you think is more dangerous?
False negative.
False negative. False positive. Okay, false negative, false. So which one do you think is more dangerous?
False negative.
I think
False
it's false
negative.
positive.
False positive.
I think it's false positive.
False positive, false negative. Okay. Now, let's look at it this way. Let's look at it this way. You see, if you say it is false negative, what does that mean? False negative, what does that mean? Let's try and interpret it. False negative, what does it mean? False negative.
Event happened, but you predicted that it didn't happen.
The event happened, is it not?
Yes.
But you say
which
it
is
did
more
not happen.
dangerous.
Exactly.
Yes,
It happened,
it's
but
more
you say it did not what happened. Beautiful. Then false positive, what is it? False positive, what is it?
It didn't happen, but it predicted that it happened.
And you predicted that it would happen. So which is more dangerous? Okay, let's take it more practical. Let's be more practical. Let's say, for example, they did COVID tests. You ran COVID tests. Is it not? You did COVID tests. So this one means that Either the person is what? Let's say positive, is it not? Or the person is what? Negative. Is that not it? Either the person is positive or the person is what? Negative, right?
Negative.
And the person is either what? Infected, is it not? The person is infected, or the person is what? Healthy. Is that not it? When you say healthy, that means not affected. Is it not? Not affected. So or we should twist it the other. I think we should put it the other way around. Is it not?
Hey, do it other way around, sir.
So that it will match, so that we can understand it with the way we have done it here. So it means this is actual, is it not? This is actual. This is predicted, is it not? This predicted means that you did the test. You ran tests. Is that not it? So it means that this person is what? The person is healthy, right? Or the person is what? Actually what? Infected. Isn't it? You ran the test, the person is what? Positive, or the person is what? Negative. Okay. So the person is actually what? Healthy. The test showed that the person is it positive or negative now? Okay, let's say the person is positive. Okay, but in this case now, we have to now swap it so that it can match. You get? But either ways, okay, let's look at it this way. The person is healthy. The person is healthy. Because so that you don't look at what to hang on to, so you just understand the concept. The person is healthy, right? Right? The person is healthy, but the result said that the person is positive. What type of this is that? Because normally a healthy person should be negative, is it not? A healthy person should be negative, is it not?
Yeah.
An infected person should be positive.
Yes,
Is that not it?
correct.
So that we'll just get it. So not use this yes, no. Okay. A healthy person should be negative. A positive person should be, infected person should be positive. I think that is correct.
Yeah.
Good. So the person is healthy. He ran the test. The results show he's negative. What is that?
Negative.
True positive.
True or positive?
That's
True
true.
or
True positive.
true positive. Can you see that?
Yeah.
This positive does not mean that
Okay.
it's
Yeah.
positive, is infected though. You get?
Okay. That means it's not infected.
It's not, it's healthy, is it not? Good. So let's look at the other one. He's infected. Is it not? He's infected. And the test shows he's positive. He's infected. And the results show he's positive. What is that?
Is it healthy or is
He's
it not healthy?
infected. He's infected. He's
Okay,
infected. And the results show he's positive.
that's correct.
So, what is that?
That's true positive.
Is that true positive? He's
Yeah.
infected.
Yes, infected and shows positive.
Is infected. Is it not? So healthy here will be positive. Infected will be what? Negative. Is it not?
Okay.
He's infected, and the result shows he's what? Positive. What is that?
True negative.
True what? Negative.
Negative.
True negative. Do we get that? I think that one is clear. Because actually, he's healthy. You predicted, or the test result came out as this. Okay? So he's actually infected, he's sick. You did the COVID test and it came out what? Positive. So that means it's what? A true what? Negative.
Negative.
Are we okay with that?
Yes.
Now, this is the question. Now, which one is more dangerous? Which one is better which one has a more serious problem? That he's healthy. He's healthy. Is it not? He's healthy. But you predicted that he's infected, that he's you predicted that he's negative. He's healthy. You predicted that he's negative. The other one is that he's healthy and you predicted that he's positive. Which one is it? He's healthy. Is it not? But you predicted that he has what? COVID. Which is that?
The more dangerous is infected but shown positive.
So that is what now?
That's FP.
So which is FP now? So he's healthy, and
No.
but the result came out as what? Positive. So this is what?
Okay, it's FN.
This is false what? Negative.
Negative.
Is it not?
Yeah.
Now he's infected, but the result came out that he's what? Negative. This is what?
That is the most dangerous.
That's the
actually.
most
False.
dangerous. Yes.
False what?
Positive.
Positive. Can you see that? Because when you look at, because you will see so many matrix, they will be interchanging them, right? So that way I want to, how you analyze it, that will determine whether it is false positive or what? False what? Negative.
Negative.
So false positive is that what? False positive is that what? He's healthy.
But
Is it
sure,
not?
false positive is
Is infected.
infected.
Is
and
infected.
but shows
is
negative.
not.
Okay. That he's what?
Infected, but shows that he's healthy.
Hmm.
But
He's
the result
infected,
shows
so
he's
this is
healthy.
negative. This is negative now, right?
Yes, he's infected, but it's showing that from the result, it's showing that he's a normal person.
Okay, so he's infected.
Yes,
Is it not?
but the
It's
result,
N.
yes,
But when he run the test, it's showing that he's what?
is a healthy person.
He's a healthy person, is it not? Which is what?
Yes.
Positive. Which is a false, is it not?
Yes,
Was it
it's
false
false.
or true?
It's false.
It's false. But remember, is it not? Under the actual, this is means it's true, is it not? This one means what? True. That actually what happened. So
Yeah.
he's truly healthy, or he's truly what? Infected.
Yes.
Can you see that?
Yes, he's truly infected, but the result shows he is not.
He's not, isn't it?
Yes.
Because that's why we see when we are trying to do this thing can be very what? Confusing.
It's
So
true.
that is why you hear this word confusion matrix.
It is confusing.
It's actually very confusing. Okay. You tested positive. Okay, let's do it this way now. Let's do it this way. Okay, you are either healthy or infected. Is it not? Healthy or infected. You tested positive. Let's do it the other way. You are either what? Healthy. Is it not? Or you are what? Infected. You are either healthy or what? Infected. You tested negative, is it not? Tested negative. Tested positive. Is that not it? Tested positive, tested negative. Okay. So you are a healthy person and tested negative. What is that? You are a healthy person. You are a healthy person and tested what? Negative.
True positive.
That is what? True what?
Positive.
True what? Positive. Okay. you are a healthy person. So anytime you are a healthy person, this is true, is it not? Because this is the actual. This is true. Actual, true. So I'll now compare it. If it's exactly with what happened here, right, then it's either true or false. If it matches with this one, then it's true. If it does not match it, then it's false. Okay. Now, when you are a healthy person, it is positive. When you are infected, it is negative. Is it not? So, which means in this case, where you are negative, it becomes what? Positive. Hey, can you see the confusion there? If you are actually positive, it means it's what? Negative.
Yeah.
Can you see it like that?
Mm.
So that means it's bad. Good, bad. Can you see that? Okay, so let's look at it now. Then you are infected. You are actually infected. Is it not? You are actually infected, which is what? True, is it not? But the result says what? You are what? Positive. Is that true? Does that coincide with this? You are infected, and the result said you are actually what? Positive. Is that correct? Was it true?
No.
You are infected. This is actually, is it not? Actually, you are infected. And the result says you are positive.
It's not correct.
And the result said you are what? Positive. You are infected. So let's think about it. So actually, you are having cough. You are
Yeah, I
having
think
cough.
it's true.
You are having cough. You are having catarrh. You have lost taste. So actually, you have COVID, is it not? You now
Yes,
go and
sir.
do a test, and the result say you are what? Positive. What is that? That is what?
Is a true negative.
Is a true
Negative.
negative. A true negative. Okay. Now, this is where the danger is. Is it not? This is where the danger is. This is where the danger is. Because this one, you are healthy. You are healthy. But it predicted that you are what? You are sick. That is false. Is it not? This one, you are what? You are sick. He predicted that you are well, which is also false. Is that not it? Now, but this one that you are sick, is it not? Is negative, is it not? So this is false what? Negative. And this is what? False what?
Positive.
False what? Positive. So which one is more dangerous?
False positive.
False positive.
Yeah.
Infected, and the result came out negative.
Okay. Now you see, based on this criteria, can you see how we have determined that this is
Doctor.
false negative and this is
Doctor.
false positive?
Dangerous based on what? Reference to what? To the patient or to
the prediction model, to the prediction model.
Because we have to take a reference. If it's the patient, then
Yes.
FN. But if it's community, then FP is more dangerous.
I like that. So you talk about the patient and you talk about what? To the community, isn't it? Now, but the thing is that remember what is happening there. We are trying to do a prediction. Is it not? We are trying to do a prediction based on the data we have seen. Now, how do we know whether we can rely on this data or this model if that model is predicting what accurately? Is it not? So when we say accurately, that means we want to see 100%, but we can never predict 100% accuracy. Is it not? So at least maybe 99% and below, maybe to 90%, right? And below. Okay. Now just imagine now you are infected. Let's look at it now. You are infected. You are actually what? Infected. But the test you have done is telling you that you are what? Negative. Is it not? Which is what? Which is what? Positive, is it not? Do you get that? You are negative. Negative means that you are well. But meanwhile, actually, you were what? Sick. What does that tell you?
So
You were-
false positive.
You were sick. But the result came out and said, oh, you are not infected. Can you see that? Infected, infected, infected. Okay, let's do it like infected, not what? Infected. So this is a prediction now. This is your prediction. This is actual. If I say actual, if I say not infected, okay, to be the other way around. Please let me not add more confusion. You know the other way around. When I say the other way around, which means I want to make one positive, the other one negative. Because sometimes when you see them, they may alternate. You get, they may what? Alternate. So just for you to understand how it's done, they may alternate. So when you say not infected means what? Not infected. Not affected, infected means what? And infected. So if I predict this one 1, I predict this one what? 0, isn't it? Not infected. Not infected. Not infected means what? You are healthy. Is that not it? And what? Infected means you are what? Sick. Infected. Let's see this one, whether it will give us a different result. You are actually healthy. The result came out and said you are what? You are not what? Infected. You know, so anytime you are not infected, it's positive. You know, you are infected is what? Means negative. That is actual, which means is what? True. So anytime this actual and this predicted coincide, is it not? When they coincide, that means it's what? True. But when they deviate, it means it is what? False. Do we see it like that? So let's look at it this way. You are healthy. The result says you are not infected. What does that tell you?
True positive.
Is what?
True positive.
True positive. Okay, true positive. True positive. Okay, true positive. So here will be what? True what? Positive. So true positive means that what? You are not what?
The actual coincide with the prediction.
With the prediction, isn't it?
Yes.
The actual coincide with prediction. Okay, good. Now, it's because maybe we are using positive and negative. If we had used the normal way, let's say you truly tested negative or you actually tested positive, isn't it? Which
Yes.
means anytime you are negative, negative means what? Negative means what?
You are healthy.
You are healthy. Is it not? Negative means you are healthy. And
Positive means
positive
you are
means what?
healthy. You are unhealthy.
Positive means what? You are infected.
Yes.
Is it not? Positive means you are what? Infected. Okay. Now, if we use that, the term in itself, positive and negative for the actual, isn't it? For the actual. So, which means that if you were positive,
Hello, doctor.
yes.
I think the example is confusing. That's why.
So, which This positive and because it has positive and negative.
Yes, because of the corona, if you are
yeah,
negative,
so
it
because
means
we
you are
say,
healthy.
okay,
Maybe you look for something that when you are negative, you are really negative. When you are positive, you are
okay,
actual positive.
okay. Where was that example that we used? Okay, we use an example of a man. So this is actual. You say you are a man. Okay, let's say you are a woman. And you are a man. Is it not? We now predicted. We now predicted that you are pregnant. Predicted you now want to run tests. You now want to run what tests? Okay, and the test shows that what is either you are pregnant or not what. Pregnant, is it not?
Yes.
So it's either that you are what pregnant or not what pregnant, isn't it? It's
Or
either you
maybe
are
you can
pregnant, either you
maybe
are
you can use
pregnant.
AIDS infection.
Is it the same thing with COVID now?
No, it's not the same.
Eh,
AIDS, if you are positive, it means you are infected. If you are negative, but COVID is way around. If you are
okay,
negative,
let's try this one and see whether this one will work.
Okay.
This one, you are a woman and you are a man. You now predicted whether the person is pregnant or not pregnant. Is it not? So where you are a woman, it's only a woman that can be pregnant, is it not? Only a woman can be what? Pregnant. Or can a man be pregnant? Can a
Transgender.
man be pregnant? Naturally, oh.
It's possible with technology.
I say naturally.
Well, naturally, it's impossible.
It's impossible. So
Biologically,
now, actually, is it not? She's a woman. She went to run tests. The test says she's pregnant. What is that?
True positive.
that's
True
positive.
what?
True positive.
Positive. True what? Positive. You are a man. You went to the hospital and ran tests, pregnancy tests, and the results say you are not pregnant. What is that?
True negative.
True negative. Can you see that? I think this one is clear now.
Yes.
You are a woman, isn't it? You are a woman, right? And you went to the hospital to run the test, and the test says you are not pregnant. Isn't it? And says you are not what? Pregnant. What is that?
True negative.
Is that true negative? You are a woman, isn't it? You are a woman, and it says that what? And you ran the test, isn't it? And it says that you are what? Not pregnant.
False negative.
False what?
Negative.
False negative. False negative. Okay, false negative. You are a man. You are a man. You went to run tests and says you are pregnant. What is that?
April Fool.
So which one is this?
False positive.
False what? Positive. Can you see that? So you see, it now depends on the test. So which one is more dangerous here? Which of them will be more dangerous?
FP.
Which one is more dangerous for you?
FP.
FP or FN? False
Well,
negative
for
or false positive? Which is more dangerous?
FN, that you are a woman and you are not.
That means you are a woman and it did not give you the right result, is it not?
Okay.
So in this case, can you see FN can be more what? Dangerous. But in the other case, FP can be more what? Dangerous.
Dangerous. Yeah.
That you have COVID, but the results say you don't have COVID. Can you see that? So it now depends on what? The situation that will now determine which danger you should take into consideration. Are we clear with this? Do we get this?
Yes, sir.
So that is why when you are now evaluating your model, right? If we do it again, when you're evaluating your model, you will now notice that here you have what? Here you have what? You have what? True positive, is it not? Here you have what? True negative, isn't it? On this positive side, so you either have false negative or what? False what? Positive. Can you see that? So this one can be this. Remember, this is my actual. This is my what? Predicted. My actual predicted. This one can be what? 1, which is my positive, or what? 0, which can be my what? Negative, isn't it? Now, if I now check, this is my 1 and this is my what? 0. Okay. So what we normally do, which one shows actually that this your result is accurate? Let's say, for example, you did 100 samples. You did 100 samples, okay? It predicted 35 of these from the 100. It predicted 5 of these. It predicted 50 of these. It predicted, let's say, 5 of these. The total here is what? The total here is what? Here is 40. Here is what? 60, right?
90.
Okay, here is 55.
55.
Let's see. Which way can we do it? So this is
95.
This is 40. Okay, maybe we'll make here 45, right? So that it can be 50. Because we said we take a sample, a random sample of 100, isn't it? They must give us the same thing. So this is 35 plus 5, which is 40. This is what? 5 plus what? 45.
That's 90. Oh,
No.
40.
This is 45, right?
Yes.
Okay. So that means here should be what? 50 now.
55.
55. Okay, here should be 50. Is it 55 or 50?
No, 55.
This is 40. Okay, this
55.
is 55. Exactly, 55. So when we add up now, it give us what? 60, isn't it?
60.
So on this side is 40, on this side is 60. When we add up down here, it's going to give us what? 40. Here will give us what? 60, isn't it? So either way, it's going to give us a total of what? 100. Is that not it? Now, which one do you think shows us accuracy? Which one will show us accuracy? If we want to know how accurate our model is, which one is the accurate one?
True positives and false negatives. True positives and true negatives.
True what?
Negative.
True positive and true negative. Can you see this one? Can you see this one? This means is what? True positive plus what? True what? Negative divided by all of them. True positive plus what? True negative plus what? False positive plus what?
False negative.
false negative. This one gives us what they call the accuracy. So what is the accuracy of this model now? What is the accuracy
120
of,
over
the accuracy of this model is what?
Like 90%.
90 over 100
90 over what? 100. Is that accurate or not accurate?
is
It's
more
accurate.
accurate.
Very accurate. You know, so that is why when you do your machine learning model, you now run this. And you now check, oh, is my model accurate or not? What? Accurate. Remember, you may try different algorithms. Which one will you take?
The most
Which one will you
accurate.
select? The one with the highest what? Accuracy. That is the same thing that happened in most of these hackathon competitions that you see, like Kaggle and the rest. They will try all the machine algorithms. They will now rank it based on who is the what, which model has the what, highest what predictory what power. So can you see how to analyze it now? Have you seen how to analyze it? If you look at it in terms of this, if I look at it in terms of this, so for example, from this positive, it was only, so we are taking true positive to what? True positive plus what? False positive. This one gives us what they call precision. It's very precise. It's called what? Precision. Can you see that? It's called what? Precision. Okay. But if you look at it in these terms, for example, from the ones that we predicted correctly, you know, as accurately, okay? So that means this is going to be what? True positive divided by what? True positive plus what? True what? Negative. This is called what? Recall. It's called what? Recall, or I think sometimes they also call it I think sensitivity. They also call it what? Sensitivity. Sensitivity. Because when we run the result, we are going to see it like this. But which is most important for us? Which is most important for us?
The accuracy.
The accuracy. This accuracy. Okay. Followed by which other one?
Precision.
Precision. Followed by what? The precision. So that's when you see, because when the result is going to come out, it's going to come out as if it's text. But now you are going to have the eye to see it like a matrix. Okay? You see it like what? A matrix. All right. So can we continue the coding now? Are we clear with this now?
Yes, sir.
Are we clear? Good. So let's just try one and see. Do we have, which data set do we even have? Which data set do we have?
The main one we have is that Superstore.
Okay, that's Superstore. Superstore. Let me see. Is there another one we can get out? Okay, let's see. There's this classic data set that we normally use here. It's called Titanic. Have you ever seen the Titanic data set? Does anybody have that Titanic data set? Titanic. You have seen it online, isn't it? You have seen it online, right?
Yes.
Titanic data set. So let me see. There's one of the library.
That one they were trying to predict who died and who did not die.
Yes, who likely survived and who did not survive. I'm sure you have seen that.
You've seen it. I've seen it, but I didn't download it.
Okay, that is a very classic case of I'm trying to remember which library we have. Either you can use these things. Which library we have it now? Titanic. Which libraries have we? We have used Seaborn, is it?
We've used Pandas, NumPy, Seaborn, Matplotlib.
Matplotlib. Okay. Matplotlib. I'm just trying to see which this thing we have that Titanic data set. Scikit-learn. Scikit-learn can have. Scikit-learn can have. Data sets can have. Scikit-learn data sets. Okay. Okay, let's do it this way. Let's do it this way. So when we want to start now, what are the libraries we need to bring in?
We import random. We import.
Import what?
Sorry, we import NumPy, pandas, mat.
Yes, we import what? NumPy as NP. Import what? Pandas.
So we're not seeing your screen now.
You're not seeing my screen. I'm not sharing.
No.
Sorry. Where's my? Okay. Where's my? Can you see my screen now?
Yes, we can now.
Okay. So import NumPy as NP, import pandas as PD. What again?
Import. Are we drawing any graphs? Could we use?
Definitely now.
Okay. Import matplotlib.
Import matplotlib.
Okay, matplotlib.
PyPlot.
Yes.
As PLT.
Then
if you want to plot it, you can also use the percentage what inline. So matplot. Otherwise, you have to always say show. But if you don't want to be saying show, then you can use this matplotlib inline. Okay, that's the essence of this one. So this will be after I finish plotting. If I want to show it, I'll say dot show. But if I don't want to be saying show, then I will just put this one there. Then Seaborn. Seaborn is what? Import what?
Seaborn as SNS.
I'm sure everybody up to this point were okay with it.
Yeah.
This is what we have been doing in the past now, isn't it? This is what we have been doing since now, right?
Yes.
This is what we have been doing. But now you see, when we want to now use for machine learning, which library do we use for machine learning?
Scikit-learn.
SKS, Scikit-learn, or what they call sklearn, is it not? Sklearn. So you can say import sklearn. Okay. Now you know this sklearn, rather than you call it sklearn, they now say from. You can just call it immediately. If I run sklearn, can you see that import sklearn? But remember, this sklearn has a lot of other libraries that we can use. Okay. So rather, for example, we have data sets in this sklearn. So let me try. So if I say from sklearn.datasets, import Titanic. I hope there's Titanic here. Titanic. There's no Titanic. Datasets. There's no Titanic here. Okay, let me check. Does it have any? Which other data sets? I'm trying to remember that which library has whether Seaborn. I don't know. Seaborn. Does Seaborn have? I think Seaborn should also have one. I don't know that Seaborn also has that Titanic data sets. I don't know if Seaborn has it, but let me see. Seaborn. So okay, so let me check the documentation. Which am I looking for now? Seaborn, right? Let me see. You have Python. Okay, there's no Seaborn here. They don't have that one here. So if you go to this thing, let's go to Titanic data sets. Titanic, can you see that Can you see cargo? Can you see my screen?
Yes.
So you are going to see cargo. So this is normal competition. Can you see that? Can you see it? Make submissions. Okay, this is the cargo. But although we still come to cargo, you see data. Now, when you see train set, test set, does it make sense to you now?
Yes.
Train set, test set. What do you do with train sets?
So you build your model.
You build your model. What do you do with test sets?
You test the model.
You now test it, is it not? Now, to now know whether it makes sense or not, what do you now do?
Put it on a matrix.
Yes, that confusion matrix, is it not?
Yeah.
Now, when you hear feature engineering, what does feature engineering mean? Feature engineering, what does it mean? Feature engineering, what does that mean? Feature engineering, what does that mean?
Is it
Do you
trying
see
to
score?
find
Feature engineering, what does feature engineering mean? Feature engineering.
is it trying to find which features are most important?
Feature engineering, feature engineering. Feature engineering. What's feature engineering? I will have explained it now how many times. Feature engineering. Okay, what is feature selection?
Bukola is saying something in the chat box.
What is she saying?
Maybe she want to loud her voice.
Creating new features from existing data. Exactly. That's feature what? Engineering. You are creating new variables from already existing what? Variables. You get? For example, which example can we give?
Like profits from sales and
Beautiful. So if I have, for example, so if I have, for example, I have sales, I have cost, you know, I can generate profit. That is a new variable. That is an example of what? Feature engineering, yes. Okay. Now, can you see this score? What does this score tell you? Score. 1 means what? This is like percentage accuracy. So 1 means what? That's 100% accuracy. But please take note, sometimes all these are 100%. So can you see 0.99? What does 0.99 mean?
99%.
99%, exactly. 100% means exactly. That is 100% accurate. You see that?
So
Then
like,
if you want to
in real
check,
life, can you have 100%?
it's not possible. Even these are 100%, some of them also have some errors too.
Okay.
But when you look at their code, that's when you now know what that makes sense or not. Can you see that? So you see codes. So Titanic machine learning, 80% accuracy. This person updated like 2 hours ago. So you are going to see the person's code book. Where is the person's code? So can you see it now? Can you see what they have done? I'm sure if we see this thing now, we'll understand what's happening. Can you see it? Now his own, he now use what? SVM. Can you see his own? SVM. What is SVM? SVM is what?
Support vector.
Support vector machine learning model. Exactly. Can you see how they are now using their own to now train and test? Which model? Which one is this?
Logistic regression.
Logistic regression. What is own accuracy?
79%.
79%.
Exactly. Okay, so you see another one, 62%, another one, 81%, is it not? And what does free lunch theorem say?
There's no one.
No one. That is why you see them, they are testing so many words, algorithms. So which one are they going to take?
The one with the
Most
highest.
accurate.
The one with the what? Highest, isn't it? The one with what? The highest. So I'm sure now, anytime we see this thing now, code book now, we understand what is happening there. So let's go back. So if I want to look for the data sets, can we download this data sets? Can we download the data set? Tests. That means I have to go and you have to log in. Is there another way we can get? Okay, let's go again. Let's check Titanic data set download Excel. GitHub is another one. GitHub is another one where, so Kaggle is where you are going to see most of this thing there, right? But GitHub is where you are going to, so you can see data sets. Okay, but this guy has a lot of data sets. So this Titanic. But how will it specify which one is test set and which is train set? Data sets. Let's say Titanic. Let's say Titanic. Raw file. Okay, but this one does not have train and test. So anytime you are dealing with this thing, if you're only giving one data set, normally you have to split it into two, train and test. Okay, but otherwise, if you don't have it that way, that means you have to now go and train it into train and test. But if you are giving the two data sets, you are giving the train data set and you are giving the test data set, then you work with them separately. Okay, then you work with them what separately. So let's see this one. So I cannot download the scripts. Train sets. Press download. Save as. We're still giving me as download. Okay, let me try and use my and log in. Okay, so I'm logged in now. So it means you have to be logged in and you have to register. So what I can do, I can download them, then test sets. Okay, done. Train sets. Download. Done. Okay, good. So maybe I can. Let me take these two files. So let me send it to you guys on the chat.
Yeah, thank you, sir.
I'll send it to you in the chat. Train sets, test sets. Okay, on the chat now. Okay, that's fine. Okay, good. Good. Train tests. Train tests. Can you see it now? Train tests. Are we there now? Are we seeing the data set now?
Not yet, sir. Which of the chats? Oh, you are seeing it?
On the Zoom
Yeah,
chat. On the Zoom chat.
Oh, okay.
There are two files there. One is train, one is test, isn't it?
Yes.
At this stage, it's expected that everybody at least should know how to import data now. Isn't
Yes.
it? So how do I import the data? Am I done with all? Okay, let's import the data first. Let's import the data first. So how do I import the data?
Test is equal to pd dot data frame.
You said test is equals to what?
pd dot data frame.
Okay, so test is equals to,
Sorry, pd dot read.
okay, test is equals to pd
PD
dot
dot
read what?
Read CSV
CSV,
brackets. So Shebi, we are inside the place we downloaded it to.
I'm not sure what. So I'll just use my define parts just in case, isn't it? So this is what, okay, this is for train. So let me use one as train. Then I will do, so take note, whatever you do for train, you must do for test. Write it down somewhere. Whatever you do for train, you must do for test. You know what will happen? So people will finish working with train data, finish all the cleaning and everything, and forget about test data. When they want to now test their model, they will now have to do the cleaning and then transformation all over again. So take note, whatever you do for what? Train, you must do for what?
Tests.
Tests. So this is tests. All right, so train, tests. All right, everybody, are we up to this point now? Now, what do you notice that is difference between both of them now? What do you notice different between these two data sets? What is different between these two data sets?
Survived.
Survived. What does survived mean?
I think
What
it's
was
whether
the-
whether the person survived or not. In real
Or
life.
not, is it not? So anywhere you see one means what?
Not
Person
survive.
survived.
One means what?
Did not survive.
One means what?
Okay, one means survived.
One means survived, exactly. Zero means what?
Did not
Did not
survive.
survive.
Did not survive or died, isn't it? Good. Are you clear with that? Now, this is on the train set. On the test set, did you see survive there?
No.
No.
So what does that tell you?
That
What does that now tell you?
we don't know whether the people
We
in the
don't know,
test.
is it not? So based on these features, I have built my model. If I bring a new data set, will it predict it? So it now say predict it for me whether this person will survive or not, what survive based on these features. Do we get that? So this is the new data. Your new what? Data. This your train data means based on this train data, what will I do? I'll break it into two first. Is it not? What are they? Train and what?
Test.
And test again. Is it not? What will be the ratio?
80-20.
80 what? 20, isn't it? So let us just try based on this one first. Because this train data that helps us what? Learn. So once we are seeing, okay, this is whether it's accurate or not
It's like
accurate.
the weather is now favorable.
Yeah, hello. If the thing is now, if the model is now predicting the accuracy, now say, okay, based on this, if you can predict this my past data correctly, there's most likely if I bring a new data set, it's most likely going to predict it. So if my prediction model is about 90%, can I rely on it? If my prediction model is 90%, can I rely on it? Can I rely on this model? 90%.
so.
Yeah, so based on that, I can now rely on it and what? Bring a new data set to start doing my what? Prediction.
But sir, do we have a standard figure that we say above this figure, below this figure, we cannot rely on it again, or above this figure we can rely on it?
You see, the target is what? 100%, isn't
100.
it? Which is 1.
Yes.
As much as possible. So the closer it is to 1, the better. You get that?
Okay.
So imagine your model is what? 0.32. Can you rely on this?
No.
Why?
Sounds very low. That's
Do you get it?
Trusted.
Exactly. Okay. So the higher the better. Sometimes you can try all your model. Your model will just stop at maybe 58%. You can try. In fact, some you can try only 32%. So in that case, what do you need to do? What do you now need to do?
To go back and find another model.
Either you now go and look for your features or create new features, or increase the sample size. So there are now different ways of now doing it. But let's go through this and let us see how it is. Now, based on this data set you are seeing here, oh, this one, they have already made life easy for us. Okay, to some extent. Okay, maybe we'll discuss that later. So let's do this now. So what else do we need to do again? What do we need to do now? What do we need to do?
The precision.
Yeah?
Test the precision or something.
How will you test precision now? How will you test precision?
I think we have to find what variables we think are
beautiful. What variables do you think you need, isn't it? Because you need to specify your model, isn't it? So which variables do you think we are going to use? So f as a function of x. So this y is my what? This y is what?
Target.
Target is target, yes. So which is my target variable?
Survived.
Survived. So means survived as a function of what variables now?
Name.
Name.
Name, sex, age.
Sex.
Sex, okay.
Yeah, they say women and children should go first.
Now you see, sometimes when you see a data set, you see, so for example, they say SIPSB. What does this one mean? Patch, what does this one mean? Fair, what does this one mean? Cabin and back, what does this one mean? So normally when you see data set, they will give you what they call data dictionary. Data what? Dictionary, so that you understand what each of them mean. So in most competitions, that's what you are going to see. They'll give you a data what? Dictionary. Okay, so that you now understand what those things mean. So if we have gone back, I don't know if that data set, whether it has any dictionary for us. Let me see, train, columns. Trying to see where they defined all the variables. Can you see data? What is data dictionary? Can you see data dictionary now?
Yes.
So data. So when they give you this things now, so the thing you're asking for is what? Where is the data or dictionary? So you understand what each of them means. Can we see that? And how well you specify your model depends on what? How you specify the model depends on what?
The variables.
Yes, now that's what we are saying. So how well you specify the model is how well you select your variables depends on what? Depends on what? depends on your understanding. That's your domain, is it not? Your domain knowledge, right? So, for example, we're asking, so what are the variables we need to take? So somebody said sex, somebody said name. Are we to take name? Are we to take name?
If maybe if you had son name, it might have made sense.
Son
Like
name
to
would
make-
have made sense.
Maybe if someone's people from certain families are more likely to survive or something.
Okay, the person's family, isn't it?
Mm.
So if that person is, for example, can we give a typical example?
If the person is a William from the William family,
So maybe that person is a royal family, isn't it?
yes.
Do you know what you have done now? You have generated a new variable from already existing variable. Can you see that? So I can now create a new column, a new variable, maybe I call royalty. Is it not? So if that person is a royal from royal family, what do I do? 1, otherwise 0.
0.
1, otherwise 0. Can you see that?
Yes.
So what you have done is feature engineering. So in that case, name, you can generate a variable name. Okay, but generally we name have matter.
No.
Generally, we name have matter, so name we don't have matter. So we can drop that. We sex have mattered.
Yes.
It may matter.
Yes.
Age matter.
Yes.
Yes. SIBSP. What does that mean?
Number of siblings.
Number of what?
Siblings.
Number of siblings. Where is
Or
it?
spouse.
Number of siblings or spouse on the Titanic, isn't it? This is a number of parents or children on board. Is it not? Then ticket number, passenger fare, cabin number, port of embark. So whether it is Queenstown, Southampton, and the rest. Okay, good. So it means which other variable is important? So siblings, parents, ticket is it important?
No.
No,
Okay. Fare, cabin is it important?
no,
Their location where they embark on is it important?
No.
Okay. P class is what? P class is what? P class. Where is P class? P class, ticket class. So whether it's first class, second class, third class, is it important?
Yes.
It's important.
Yes.
Okay, so if it's important, then we'll take it. Okay, so we can take it now. So how many did you identify? We have taken P class, taking what?
Sex.
Is it not? Age, this,
4,
and
5.
this. All right. So what have we done now? So in our new data set now, what do we want to do now? What do we want to do now? We want to what?
We want to take only those features we're interested in.
Only those features we're interested in. So how do we go about it now? Please don't forget, anything you do to train, do to test. Because we see that we spend so much time on train and forget that we are doing tests. Okay. All right. So how do we extract that?
It's just to call the columns. That's
So how do we call the columns?
train
Columns,
columns,
right?
train brackets. Then we'll start writing the columns we need. Is it double columns? Double columns. So
Okay.
double brackets rather. Yes, double brackets.
Yes.
Then
we can just copy, right? Copy and paste. Then which one don't we need? Age. Do we need tickets? Do we need cabin and backs? So we don't need these ones, right? Is that all? So this embarked, fair, siblings, okay. So this is what we have, right? So if I call it train equals to, we understand this, or should we call it another name? Let's call it X. Okay, let me call it, what else can we call it? What should we call it? Okay, in fact, you know what we can do? You see that this is our model, this is our Y, this is our X, isn't it? This is our Y, this is our what? X. All these ones are our what? X, isn't it? So what I can do, we can take just this as our what? X. So let's call this one X. So if I call X, we understand this now? Do you understand this?
Yes.
Then if I call Y, what is going to be Y now? What is our Y?
Survived. Train.
Yes.
Survived.
Train. Survived, right? Survived. If I run Y now, do we have it there now? Now, take note of something. If I look at this, my X, right? If I run X now, let's run X. This X now, take note, when you are running your regression, everything is supposed to be what? Quantitative data. Isn't it? So we can now see male, female there. Male, female, is that a quantitative data?
No.
Male, female, is that a quantitative data?
No.
So what do we now need to do?
Convert it to a format we want. We can say sex is equal to male, and for every male to be represented as 1.
Okay. So if I am interested, or maybe a specific, this is who is going to survive, isn't it? So where what now? Where male is what now? Or so, for example, if we're on board now, who are they likely to evacuate first, male or female? If maybe
Female.
there's crisis now, who would they evacuate first, male or female?
Female.
Female, isn't it?
Yes, sir.
So that means that anywhere we see female, we are going to assign what? 1, is it not? Anywhere we see female, assign what?
1.
Otherwise,
0.
assign what?
0.
So how do we do that? So how do we do that now? Yes. How do we do that? This one we have, I think this one is pandas. Now, this is not even anything about machine learning. This is pandas. So how can we do this? Yes. How can we do this? Yes, how can we do this? We want to assign anywhere you see female, assign 1. You know, anywhere you see male, assign what? 0. So how can we do that? Although there are different ways. How many ways have I shown you to do this? You can write a function, isn't it? You can use map, right? You can map it. So for example, if I say, what is x? So this is x, right? So this x is what? 6. If I say, so let me call, okay, let's say x, let's call it gender, right? So let's call it gender. So gender is equals to what? X dot what? Map. What are we mapping? Anywhere I see what? 1. Is it not? Or anywhere I see what? Is it female? Okay, anywhere I see female. Anywhere I see female, call it what? 1. Otherwise, anywhere I see male, please remember it's case sensitive. Anywhere I see male, assign what? 0. Is that how we do it? Enemies have come. So gender, let's see. What did he say? Data frame has no attribute map. Has no attribute map. Data frame has no attribute map. So let's see. Okay, so let me call. What has happened? Why is he giving us this error? Why is he giving us this error? Hello. Why is he giving us this error?
There is no gender there.
There's no gender there.
What we have is sex.
What we have is what? Sex, isn't it? So what we would have done here, so it means that on that X, we want to create a new column called gender. And here it will be what? Is that sex? Let's run X and check. Did it bring gender now? Has it worked? Has it worked?
Yes, sir.
It has worked. Okay, so what we can do, I can just quickly copy this out and say for my X, I'm going to drop this sex now, isn't it? And have what there? Gender. And I will run it. Sorry. So on my X now, sorry. On my X gender. All right, let's run and check. So is this correct now? Is this correct? Is this correct now?
It is correct, sir.
Okay, good. Y, this is my Y. Okay. So what do we need to do now? So normally we are expected to do a lot of pre-processing, isn't it? But for now, I'm not going to bother you pre-processing. So maybe when we meet again, we'll discuss it. So if I want to bring in all my libraries now to run the machine learning model, what do I do? I will have to bring in what? My libraries, isn't it? So I say from what? sklearn.linear model. import, which algorithm are we going to use? What kind of problem is this? What kind of problem is this? What kind of problem is this? What kind of problem is this?
That's
Yes.
binary.
What kind of problem is this? What kind of problem is this?
Classification.
It's a classification problem, isn't it? Which algorithm can we use under classification? We can use the logistic regression. Logistic what regression, isn't it? Then once that one works, you can also bring the other libraries. So you can say from, you can also do the confusion matrix, or remember the other one from sklearn dot model what selection import what train test splits. Can run that one to check. Okay, that one works. Then maybe you can also bring from sklearn dot matrix import. We can bring in confusion matrix. Okay, let's say import. Let's say accuracy score. Accuracy score, and you can also bring in confusion matrix. I'm sure we understand what's happening here, isn't it? So once we have done that, we have got our X, we have got our Y, right? We need to first of all do the train and test. This is not, we need to break it down. So we have it as X train, X tests. Oh, I have to join this now. Y train and what? Y what test. I'm sure we did this one last week now, isn't it? So we have train, tests, splits, X comma Y. What is our test size? What is our test size? What is our test size? Yes. Test size will be what? What is our test size? Nobody's following.
0.2.
0.2. Then you can use the random states. Although the random state, you know, you can pick any one that you want, right? You can use the default one. You can use 100. You can use 4. You can use any number you want. Okay, just to ensure that we pick the same number. So you can use 42 there, any number you want. So once you have done that, remember what we said. Anything you do for train, you do for test. But for now, I'm not going to bother you with the test. You do the test yourself. So if we were to run the regression now, so what do I do? And I need to call the instance. You know, so I say which model is this? Let's say linear model or linear logistic regression, or you can just call it model. Let's say model. We can say logistic regression. So we have created an instance now. So instead of calling logistic regression, we're calling it what? Model. So what do we do? Model dot what? Fit. What are we fitting? Our what? X train and our what? Y what? Train. What has happened? Input contains NaN. When you say input contains NaN, what does that mean? What does that mean? Contains NaN. What does that mean? NaN? What does NaN mean?
Is this space?
NaN, what does NaN mean?
Not available.
Not available, that means it's missing data now, isn't it? So normally we're
Yes,
supposed to
sir.
have done pre-processing. We are assuming the data is clean, so we're supposed to do pre-processing and remove all. So how do you check if there's a, so let's say train, How do I know if they are missing data here? Sorry, on my X data, how do I know there's missing data there? How do I check if there's missing data? Train dot what is null, isn't it? Let's say dot sum. So are there missing data? There's missing data there now, isn't it? So on
Yes,
age.
age.
So what can we do? So what can we do now?
You substitute.
We can say, what can we now do? We can say X age. What can we do there? Either we can fill NA, is it not? Or drop. Okay, let's say we want to fill it with maybe the median age. So we can say, what can we do there? You can say X what? Age dot what? Fill NA with what? What is the data? X age dot what? Median or average? If we say median, should it be permanent? In place equals to what? True. So let's run that. Let's run that and check now. Hello, enemies at work. Enemies at work. So all the missing data now we have converted it to what? Okay, no, I have to go and join another session right now. So when are we meeting again? Are we tomorrow is public holiday? Can we meet tomorrow? Can we meet tomorrow?
Yes, we can.
We can meet tomorrow, same time. So if we can meet tomorrow so that I can finish out this machine learning. And I know we are done, we can be done with Python as soon as possible.
We can conclude the time on the WhatsApp chat.
Okay, that's fine. Okay, that's fine. But try and go through it and go and do your pre-processing to clean the data up. So remove all those NAs. Then tomorrow when we come, we'll run the model. Okay. All right, guys.
Thank you, Dr. Francis.
All right. See you tomorrow.
Thank you, Doctor.
Bye.
Thank you, Doctor.
Bye.